Hi students, welcome back to our e-learning PHY260 for sound. 4.3 Interference of sound wave. In the previous slide, we only discussed if we only have one single sources. But what if we have two sources? What happened to the sound wave? These two sound waves will interfere with each other. So we call this as interference of sound wave. Two traveling waves which exist in the same medium will interfere with each other. If their amplitude added in a bracket in phase, it will produce a constructive interference. If their amplitudes cancel each other or out of phase, it will produce destructive interference. Figures shows that two speakers produce sound and both of the waves will intercept each other. There's a point where the sound waves are in constructive interference, where you're going to hear loudest sound. But at a certain point, you're going to get a destructive interference, where the sound cancel off. At point C, it will produce a constructive interference. At point D, you're going to produce a destructive interference. Sound waves will interfere with each other. When both of the sound waves interfere, there will be a path difference. The path difference for constructive interference is either 0, lambda, 2 lambda, and so on. While for destructive interference, the path difference is lambda over 2, 3 lambda over 2, 5 lambda over 2, and so on. Beats. From the previous slide, both constructive and destructive are said to have same frequency but are at the different phase. But for beats are actually periodic rise and fall in intensity that can be heard when the two waves are relatively close in frequency. Beats occurs as a result of superposition of two sound waves of slightly different frequency. From the figure below, you're going to see that two waves combine and there is a certain part where you're going to get a largest amplitude and at another part you're going to get a smallest or cancel out both of the amplitude. So at a largest amplitude, you're going to hear a loudest sound. How to calculate the value of beats? The frequency of beats is the number of intense sounds heard per second. The beat frequency is always equal to the difference of the two nearly equal frequency. So bit frequency is equal to modulus f1 minus f2, or bit frequency f is equal to total bits divided by time.